So this is a very tricky question. That is a construct binary tree from preorder and inorder traversal. We have to construct a binary tree from preorder traversal and inorder traversal. Given two integer arrays, preorder and inorder, where preorder is the preorder traversal of binary tree and inorder is the inorder traversal of the same tree. Construct the binary tree. So basically, you should know the basics of pre-order and in-order traversals, and obviously basics of binary tree. This is a tricky question, but it's very easy if you know the definition of pre-order and in-order. What is a pre-order traversal? Let's try to analyze that. What is pre-order traversal? So here they have given us the tree, right? So pre-order definition of pre-order is always root comes first, always root comes first, then it traverse left and it traverse right. This is called as pre-order traversal. Simple definition. Just try to understand definition. Okay. So pre-order is root. It will process the root first. These are traversal methods. So it is going to traverse on this particular tree. And what is pre-order traversal? It always the root is first, then it goes root. It process the root first, then it process left nodes, and then it process the right nodes. Then in this example, let's see what is pre-order traversal. Pre-order traversal is first, the pre-order traversal is the root node. What is root over here? 3 is the root. So 3 becomes our root. Then it processes the 3. That's the reason I added it in my array. Now, then it goes to the left. It processes the left also. So I add it in my array. So 9 is my left. There is no children, so we don't have to add over there. Then from here it goes to right. It goes to right. In the right, you see this is the root. So it processes the root first. That is 20 I added in my array. Then it processes the left, that is 15, which I added in the array. And then it processes the right, that is 7, which I added in the array. So this becomes your pre-order traversals. This becomes your pre-order traversal. So if you see, they have given this as a pre-order traversal in the question. They have given this. You see here, they have written pre-order 3, 9, 20, 15, 7, and same is our pre-order. So always root comes first. This is very important. Root is first for pre-order traversal, and then it process left, and then it process right. Now, what is in-order traversal? Let's check what is in-order traversal. So for in-order, let me rub this. That's better. For in-order traversal, we are going to process first left node. We are going to process first left node, then we are going to process the root node, and then we are going to process the right node. This is the definition of the in-order traversal: left, root, and right. This is how it works. So let's see how we can traverse in our tree. So in the array, I will start from 3, right? I'll start from 3, but I'm not going to process the root because in-order traversal doesn't process the root first. So I'm not going to start from the root. I will be starting from the left node, that is 9, and I'm going to process that node first. So I will be writing 9 over here because always left come first in order traversal. And from 9, I will again go back to my root and then process my root. So I write 3 here, then go to right. In the right, if you see, 20 is my root, right? 20 is my root. So I'm not going to process the root. I'm going to process the left. What is my left? 15. So I will be writing 15 because this is my left. This is my left. And then again I go back, and what is my root? My root is 20. So process the root and then process the right. This is my in-order traversal. This is my in-order traversal. Simple. I'm breaking down the step-by-step sub problems of this particular question so that you understand better. So in-order traversal is first is the left node, then is the root node, and then is the right node. So when we start over here from the root, we are not processing the root first, we are processing the left first, and then come back again and process the root. This is how we are going to do it. This is how we are going to do it. And this is in-order traversal. If you see, this is our in-order traversal, which they have already given. Same numbers of arrays, same number, because we always process left first, and pre-order we process root first. Now let's see how to construct a tree with this particular array. So the basics are clear now. What is pre-order and what is in-order? So let me write here what is pre-order traversal over here. It is, we have 3, 9, we process 3, that is root first, then go to left, that is 9. Oh, sorry, pre-order 3, then 9, then and then we are processing the root again, that is 20, then 15, and then 7, right? This is the pre-order. And what is the in-order traversal? What is the in-order traversal? In-order traversal is nothing but left first. So left is 15, then we process 20. Oh, sorry, this is not the left. I'm sorry. So the left is 9. Left is 9, then we process 3. Then we go to 20, but we don't process 20. We process 15. Then we go to 20. And then we process 7. Now let's see how to go ahead with this. Okay, how we are going to go ahead and construct a binary tree over here. If you observe, for constructing a binary tree, we should know the left array and the right array. Okay, basically we should know these two arrays. What numbers will go in the left direction and what numbers will go in the right direction. But how we are going to know this? How are we going to know this? We are going to know this with the help of the root. We are going to know this with the help of our root. And basically what I told you, where do I find the root first? I find the root first in my pre-order traversal. So I find the root in my pre-order traversal, and this root I'm going to map it in my in-order traversal. So in my in-order, my root is over here, right? My root is over here, so I'm mapping it in my in-order traversal. So in my build tree function, in my build tree function, what I'm going to do is I'm recursively checking in my pre-order, where is my root. Okay, I got the root, so I'm putting it in my build tree function, and in the in order I'm just going to map that root. Why I'm going to map it? Again, I should know what is left and what is right. I cannot know in the pre-order where is left and what is right, right? I cannot know. But in order I know where is left and where is right, obviously, because the definition of in order is that all the numbers which are towards the left of the root is left, and all numbers towards the right of the root is right. This is what in order definition is, right? Come again, let me tell you again what is in order. You know that, right? We are processing first left, then the root, and then right. So according to that definition, we can understand what is our left tree and what is our right tree. That we can understand only by the in order traversal, in order traversal array. So now I processed the root, and I just took the root, and I took this root from my pre-order traversal, because pre-order always root is 0, and that root I am mapping it to my in-order traversal, so that I know what is my left and what is my right. Now, next thing, once I know what is my left, right, I am going to again check in my pre-order where is my 9 in this pre-order, and I get over here, this is my 9 and this is my 9. So I'm going to add my 9 in my build tree function. And you will ask me, how come you know that left tree does not have any children's? Left tree does not have, see here, there are no children's over here, it doesn't have children's, because in order there is only one number, right? Only one number. So we know there are no children, so therefore we are writing null over here. So we understand that there are no children's, because there is no number other than 9 in order traversal. And same thing works with the pre-order, because we know there is only one number in order. So obviously in pre-order also, that 9 is alone, there is no children's over there. Once we understand that, it's very easy, because we know what is right. Now we know the right is always this part portion, because uh, in order, whatever towards right of the root is always right. So we know that this is our in order traversal. Again, over here we can see the same thing. Our root always starts from the first letter, so this is our root. So we can mention that, we can mention that as our root, and then the left subtree and our right subtree. That is very easy to understand, because see, we once you understand the root, right, this is our root, right, this is our root. Once you understand your root, right, then you can easily detect that, okay, this is our left subtree and this is our right subtree, because in order to reversal always have the left, always have the left subtree towards the roots left, and right towards the right of the root. So that's how we are deciding. So basically, let me tell you again, basically what we are doing is we are just simply working on our building tree, right? We are building tree, and we are building tree with the help of the in order and in order traversal and uh, pre-order traversal. That is how we are working on. So when we are working like that, we have to think that what will be the root. So when we ask ourselves what is the root, we know that pre-order is always the first index, is always the root. So this comes our root. And what is towards the left, to understand what is towards the left, we have to map it to the in order traversal and check into the left side, and we get the left side. Okay, we have got it. And that is how we are getting it, right? We are getting that because we understand that towards the root we have the left subtree, and towards the right of the root in the in order we have the right subtree. So this is our right subtree. And in the right also, how to understand which is the root, then you go back to the pre-order and check what is the next number, 20. So yeah, 20 is our root, 20 is our root. And what is towards the left, what is towards the left, 15 and 7. So again you can say that 15 is our left subtree and 7 is our right subtree. This way you can build this particular tree. And yes, it is little tricky because you should know the basic things of pre-order and in order, and then you can construct this tree easily. So let me show you in the code like how to do it. Public tree node, pre-order, in order. Let's say build tree. This is already given, and if there's a base condition, if pre-order dot length equal to 0, or in order dot length equal to 0, then return null, because then we know that there is nothing to return over here. Then first thing first, we are finding always the root, right? As I've shown in the diagram, we find the root. So I'm just writing that, initializing the root with zeroth index, and then we have to know what is the zeroth index. It is mapped where. So to understand where is the mapping, I'm writing this, I'm traversing in order, in order way, in order array, I'm traversing it. I'm iterating it, sorry, not, I'm iterating the in order array, and I'm just going to map the root, so that I know where is the root and where is the left and where is the right. So I'm just mapping pre-order of 0 is if it is same to in order of I. If it's same, this will be starting from 1. If it's same, if both are same, then mid is nothing but I. And here I have to initialize int mid equal to 0. So I'm just trying to understand what is the middle point, what is the root, and what is the mid point. Once I do that, I mapped it. Now I understand uh, what is the left, root dot left, Let's write root dot left will tree. What will come? I'm using arrays dot copy of range because I have to give the range in this. So what will come in the left for the pre-order? What is the left? What is the left? Left starts from 1, right? Because the 0 is taken by the root. Pre-order's 0th index is taken by the root. So the left starts from 1 and it extends till it starts from 1 and it extends till mid plus 1, which is not inclusive. Then what is the left at in order? What is it? This is like we have to map it. So what is the left at in order? The left at in order starts from 0th index, right? It starts from 0th index, and the left ends in mid plus 1. So again, this is not inclusive. So we can write mid plus 1, and then we have to write the right subtree as well because we are constructing this. So let me write root dot left, and this is like a root dot right. So this is like a recursive function which I'm writing. And again, I'm just going to copy this line, entire line. I don't have to write everything again. So we are going to define now right subtree, right subtree. Left is done. So for the right subtree, the range will be, it will start from mid plus 1, right? Which is not inclusive. From mid plus 1 it will start, and it will go till the length of preorder dot length. So it will go till the length of preorder dot length. And same for here, in order also it will start from mid plus 1, and it will, here it remains same because once you understand the difference between right and left, then the right remains same because it starts from mid plus 1 and ends till in order dot length. And in order dot length, and that's it. And then we have to return the root. This was a very tricky question, but once you understand what is coming towards left and what is coming towards right, it becomes easy, and that you can understand with the help of pre-order definition and in order definition. Thank you for watching.